Welcome to Developing Graphics Frameworks with Python and OpenGL, Part 8, Vertex Buffers and the Attribute Class. In the previous video, you finished your first GPU-based application, which was to render a single point in the middle of a window. And that shader code was extremely simple. You might recall in the Vertex shader, you actually hard-coded the position of the point. But in order to define the shape of anything in 2 or 3 dimensions, you're going to need multiple points, and this approach does not work in general. So starting in this video, you will learn how to store arrays of positions of points and other data in vertex buffers on the GPU. The first step in this process is to learn about the OpenGL functions that you're going to need to work with these buffers. And then you'll use these functions in a class, which we will call the attribute class, which will automate this process for us and make it easier to draw more complicated shapes. Now, most of these tasks are going to take place in the initialization stage. When you initialize the application, you'll generate the data which defines your shapes, and you will upload all of it to the GPU. The tasks that you're going to need to perform, they're handled by 6 different OpenGL functions, which we'll review first before we start writing code. So, to begin, the first function you're going to need is to generate the names of available buffers. So, you don't get to pick the name of the variable on the GPU. What you need to do first is call this function here, glGenBuffers, and that will return one or more buffers. The number of buffer names is specified by this variable, buffer count. It'll return available buffer names or available buffer references, which you can use for creating buffers. So this will give you some ID numbers, you can think of them as. It'll return some integers. And then we don't actually write data into the buffer directly. There's an interesting paradigm which is used when you're programming in OpenGL called binding. And the idea is you'll take a reference of an available buffer, which you generated with glGenBuffers, and then you're going to bind that reference to a particular target. And then other functions which you want to affect this reference, like when you want to later on update or upload data to this buffer, you will upload data and specify this bind target. And then it will affect the buffer which is bound to this target. It'll make more sense once we start writing code. And so glBindBuffer is a function which is going to create the buffer object referenced by bufferref. The first time it's called, the object won't exist, and it'll initialize that object, and then it'll set up the binding. The next function is glBufferData, and that's the function which will actually upload data to the GPU for you. But notice this function does not take buffer reference as one of its parameters, right? It takes bind target as a parameter, and so it's going to affect the buffer which was previously bound to that target. So in this function, to actually upload data to the GPU, you need to specify the target. The second parameter is the data, which is going to be sent into the buffer. And the third parameter, it's your best guess on how the data is going to be used. Is it going to be static data that's just sent once and just stays? Is it going to be dynamic data that's going to be updated frequently? Usually data you upload to the GPU will be static. You won't be updating it too frequently. But buffer usage, it's kind of a hint to GPU, and it'll help it optimize the performance of your application. And so those are the first 3 functions you're going to need. The next 3 functions, the first one is called glGetAttribLocation. Again, when we're working with variables in the GPU, right, we'll have our shader program, our Vertex shader, and we'll define some variables in there, but we need the references to those variables, right? We don't assign data to a variable by name, we assign it through its reference. So given a program that we've previously initialized with this program reference, this function, glGetAttribLocation, it will look for a variable with a specific name, and it will return the reference to that variable. And it's that reference you'll use later on. The next function you'll need is going to set up the association between the buffer and the variable that's declared in this shader. And this is really important. It's kind of, it connects the different parts of your program. Right, so this, you might notice this function does not actually have a bind target reference. It's automatically going to target whatever buffer was previously bound to GL array buffer. Right, usually your vertex data is stored in an array because you have an array or a collection of vertices or points defining your shape. So, taking the variable reference that was generated by glGetAttribLocation, it'll take this variable reference and it will basically supply this variable with the values stored in the buffer that's currently bound. The other information it needs to set up this association, it's going to need to know what type of data is stored in this buffer, right? And so base type will usually be either integer or float data. Booleans are treated like an integer, 0 or 1. And you'll need to specify the size. Here, size refers to how many components of this base type you have. So for example, let's say you had a vec3 containing float data. In that case, size would be 3, a vector of 3 components, and your base type would be float. The other parameters, normalize, stride, and offset, we're really not going to need in our applications too much, but normalize, if you had vector data, that would automatically scale it or normalize it so it has length 1 or magnitude 1. Stride and offset, these are often used if you're packing different types of data into a single array, if you're kind of interleaving different data. Like you could create a single array that contains both position and color data, for example. This would help the function understand how to extract data from that array and assign it to that variable. But in general, we'll use a different buffer for each attribute. So these 3 parameters, we'll just assign some default values. The last function we need, GL enable vertex attrib array. Even if you set up this association, you kind of have to enable it. I think of it as you set up the wiring and then you have to flip the switch to turn it on. Right? This specifies that when you run your shader program, that the variable reference will in fact be accessing the data stored in the buffer. And these are the 6 functions you're going to need in order to upload data to the GPU for vertices. All right. So it's a very theoretical description of what these functions are. I think it'll make more sense once we practically implement it in code. So we're going to go ahead and let's start up our Sublime Text or whatever your development environment of choice may be. And we're going to create an attribute class. And it's going to use all 6 of these functions. All right. So previously, we have a couple of test functions. I'm going to go ahead and close those. This is going to be some of our core code. So I want to create a new file in the core directory. So I'll create a new file, and I'll save this right away. It's going to store an attribute class, so I'd like to name this file attribute, attribute.py. I always use a lowercase letter to start the file names and a capital letter to actually start the classes. All right. So here, we're going to need to do a couple of imports. We're going to need to import the NumPy library for the first time. That gives us really nice functionality for working with vectors and matrices. And since we're also using OpenGL functions, we need to import the OpenGL library. And I'm going to do this in a slightly different way than we did in the OpenGL utils class. In the past, we said from OpenGL import GL, And then we'd have to reference functions as GL dot. Then I noticed in the last class we had a lot of instances of GL dot GL, and that felt kind of redundant. So what I'd like to do is import all the functions from the GL package in OpenGL. So I'm going to write this a little bit differently. I'm going to write from OpenGL.gl import asterisk. Right, this way I won't have to preface everything with a capital G and L. And at the end of this video I'll also make the corresponding changes to the OpenGL utils class just to make it a little bit simpler. Alright, so we're going to create a class called attribute, this time with a capital A. I always like to use the notation which indicates it's an object. And as always, we first need to start a constructor. And the constructor is always define underscore underscore init underscore underscore. This is an instance function, so I start off with self. And really two parameters to initialize an attribute. I need to specify the type of data. It's required information from one of the OpenGL functions. And also I need to supply the data itself from an array. So I'm going to go ahead and say self data type. This is going to be a string, and then just the data itself. So let's define this function. Let's see, the first part is going to be the type of elements in the data array. And to start, later on we'll use more different types of elements, but for now the basic types are going to be int, float, vec2, vec3, and vec4. And by default, vec2, vec3, vec4, they are vectors containing floats. There is such a thing as an integer vector, but we're not going to have an occasion to use that. Right, so self.dataType. I want to store this in the class. I'll just assign the value of the parameter data type. Next, I'll have an array of data that's going to be stored in the buffer. To be stored in a buffer. And we'll save that in the class self.data equals data. And next, we get to start using our OpenGL functions. So we need first a reference to an available buffer in the GPU. And so I'm going to generate this. We'll call it, what should we call this? Bufferref. Bufferref equals GL gen buffers. And we really only need to generate one. And again, notice that the syntax for this function is a little bit different. In the previous video we used GL dot, but again the GL.gl felt a little bit redundant. So thanks to this new import style, I can just call the function directly. All right, and to upload the data, I'm going to create a function which can be used to upload it. So we're going to upload data immediately with a yet to be defined function, self.uploadData. I really want to separate out this functionality in case you need to re-upload the data later on. If for some reason your attribute data changes, this class will be able to handle that. All right, next function is going to be the upload data function. So let's use comment here. Function is going to be to upload this data to a GPU buffer. And so we'll define upload data. I don't need to pass in any parameters. The data was already sent within the constructor. All right, the first step, to work with PyOpenGL, we actually need to convert the data to NumPy array format because that's what PyOpenGL uses. So first, we'll go ahead and convert data to NumPy array format. And I want to make sure that the data is stored as a float. Right? Even if it looks in Python, if it looks like we have integer data types, I don't want OpenGL to infer that it's a data type. So we're also going to convert, in the same line of code, convert to floats. So we'll say data equals numpy.array self.data. Right, so this by itself just converts a Python array or a Python list to a NumPy structure. But I'll also add in as type numpy.float32, a 32-bit floating point number. All right, so now the data is in a compatible format. Let's go ahead and select a buffer that's going to be used by the following functions. And here's where we use our second OpenGL function. I'm going to use gl bind buffer. We're going to bind something to an array buffer, and specifically that buffer reference that we generated before. All right, so this in essence activates the buffer, so the commands that come next will target buffer ref. They're targeting it indirectly through gl array buffer. All right, so next we're going to actually go ahead and store the data in the currently bound buffer. Right, and we do that with our next command, our next OpenGL command, gl buffer data. Again, we're targeting whatever is bound to the current array buffer. Let's see, so data, this is a function which is needed just to process the data, and we're probably not going to change the data. It's going to stay static, and that's what that constant is used for. All right, excellent. Okay, so this function takes care of uploading the data for us, but we're not done yet. We still have to tell OpenGL the data from this buffer is going to be associated to what variable in the shader program. So that's a different task, so it makes sense to kind of put that in a different function. So we're going to go ahead and define a new function. Let's call this new function associate variable. Self, we're going to need the reference of the program that contains the variable, and we also need the name of the variable in the shader program that it should be targeting. And let me add in a comment here. I just want to comment what these things do. We're going to associate a variable in the GPU program with this buffer. All right. So first, I need to learn how OpenGL is going to refer to this named variable. So I need to get the reference for the variable. Let's say get reference for program variable with a given name. And so variable ref equals gl get attrib location. Right, within this program, find the variable with this name, right, and return its reference. Okay, that's step one. Next step, it could be possible that there's some kind of a typo here. It could be possible that the program just doesn't use this variable at all. So that's an easy check. Right, so if the program does not reference the variable, we're going to exit. So, or we're going to use return. The reason being, you don't want to try to upload data to something that's not there. That just doesn't work. Right, so if variable name is not present in program ref, it returns a value of -1. So that's what we're checking for here. So if variable ref is equal to -1, we just go ahead and return. And one kind of interesting thing, a little gotcha that happens sometimes, when OpenGL compiles a shader program, you might have variable names in there. If the variable name is not used, OpenGL will actually delete it from the compiled program, and it would return a value of -1. This has happened to me personally. I've written shader programs, I've left some kind of placeholder variables in there, and then when compiling, OpenGL just deletes the references entirely, which triggers this -1 return value. So, right, so the program does not reference the variable or use the variable. Otherwise, if we get to this point in the function, the variable's in the shader, and we can go ahead and set up the buffer and then specify the association. All right, so right in here, let's say the next step is to select the buffer used by the following functions. And we're binding the buffer again, right? And we did that before, right? When we did upload data, we did GL bind buffer. In fact, I can just copy this line of code right here for convenience. The upload data function might be called at a different time from this associate variable function. So we have to make sure and rebind the correct reference. So same line of code here, right? And by binding this buffer reference, the next command will apply to this buffer reference. And so now we're going to go ahead and specify how the data will be read from the buffer currently bound. And this particular command only applies to array buffers. All right. Now here is when we use the GL Vertex attrib pointer function. Remember, it takes the different parameters based on the base data type and how many components it has. Right? This is why we needed to store data type. So we're going to have a whole block of statements here. For example, if self.datatype is equal to int, right? This means it's just a single integer. In that case, we'll use GL Vertex attrib pointer. Right, the variable with this reference, there's one component. That component is an integer. Then the last three parameters, again, they're if you're packing lots of data for different attributes into a single array, which we're not. So the last three arguments will always be false, 0, and none. There's nothing to see there. And now, the other possible cases for the other different data types. Else if self.datatype is equal to float, a single floating point number, GL vertex attrib point, and variable ref. In this case, we have one float number, false, 0, none. Right, and we've got more and more statements like this. So let's see, what if the data type is equal to vec2, a vector containing two floats, GL vertex attrib point, variable ref, two components that are both floats, false, 0, none. So now the other kinds of vectors, next data type is a vec3, GL vertex attrib point, scroll this up a bit, variable ref, three components that are floats, false, 0, none. And the last case for now is a vec4. We'll see a lot of vec4s. Elif self.datatype equals vec4. Probably noticed a pattern by now. GL vertex attrib point, variable ref, 4 floats, false, 0, none. All right, and just for our own sake, let's do an else. At this point, you've defined an unknown type, so let's just raise an exception. So unknown attribute type plus self.datatype. Right, just in case of a typo, let's go ahead and catch that. All right, and then the last thing we have to do, even if you set up the association, even if you connect the wires, you have to flip the switch to turn it on. So last command, indicate data should be streamed to variable from a buffer. Right? And we do that with GL enable vertex attrib array. Just turn on this variable reference. Phew. All right. So it's quite the class, but it's an extremely useful class. We don't want to have to keep typing in this code again and again, so that's what makes it a good candidate for the class. All right, fantastic. So this uses the 6 OpenGL functions that we discussed, and then the next step is going to be, well, to write a program which defines some attributes and uses them in the corresponding shader programs. But we'll save that for the next video. Thanks for listening.